friends, this video on Semiconductors Part 1 is brought to you by examfear.com. No more fear from exam. Topics to be covered in this lesson are history of semiconductors, what are semiconductors, energy band concept, semiconductor types, PN junction, semiconductor diode and its biasing, junction diode as a rectifier, junction transistor, transistor configuration and characteristics, transistor as a switch, transistor as an amplifier, and digital electronics with logic gates. So what do you think are we going to study in this lesson on semiconductor electronics? You can say that now you are going to study a new branch of science altogether. Electronics is something which I think you are studying for the first time, right? So what are we going to study in semiconductor electronics? I mean, can you guess something from the name semiconductor? Yes, of course, you can. It sounds somewhat like conductor. You have heard of conductor, right? Substances which are good conductor of electricity, they are all conductors. So here we are going to study about semiconductors. That means maybe an object which is partially conductor of electricity or something like that. We'll see all that in detail as we go ahead with the lesson. But before that, in this slide, as we always do, what will we see? We'll see what is the purpose. I mean, why are we going to study this semiconductors? I mean, what is the purpose behind it? Objects which you see around yourself, all objects like your laptop, your computer, a transistor, a tape recorder, your microwave, your refrigerator, your cameras, your video recorders, batteries, calculators. There are so many things which you see around yourself, and all of these have application of semiconductors. Semiconductors are used in each of them in some or the other way. So do you think these are something which you really don't need in your life? I'm sure all of you must be using such things. These mobile phones, laptops, computers, they have become so common these days. So you understand. So before you begin to start learning something new, you should always know what is the purpose behind learning that, because only then you will get that to go ahead with it, right? So since semiconductors have got so much of applications, so it is worth enough to study in detail about semiconductors. What happened not long back, so far we have studied about electric circuits, right? We studied about resistors, capacitors, inductors, transformers. We have seen all these things so far, right? I mean, all such kind of things. We have seen so many other things as well, like we have seen AC generator, DC generator, DC motor. We have studied about quite a lot of things so far. Try out something like this. If you look at any circuit, for example, if you try to open the CPU of your computer, what do you see inside? So many circuits, right? And it's like a small board with so many resistors, capacitors, inductors, only these things. Behind this, you also get to see certain new things like diodes. I'm sure if any of you would have observed any circuit closely, you would have seen all these things. You'll come to see diodes, you'll see transistors, you'll see ICs. What are ICs? It's like an entire circuit which is built on a very small chip. It's very small. You get to see valves. So now you see some different kinds of things as well. So what are these? These are nothing but applications of semiconductors. So semiconductors are a group of substances which have got some unique characteristic of its own and which can be made useful in various electronic applications. And that is why we study, and since the concept of semiconductor is very vast, so we study semiconductors almost as a different branch of physics. I mean, if you go for higher studies in physics, you will have your solid state physics. So that solid state physics is nothing but it will talk only about such things, right? So this semiconductors is a very vast subject to discuss. However, here, as per your curriculum, we will just touch the basics of semiconductors. Now, once you are clear with the basics, you will have no issue understanding things at higher levels as well. So please pay good attention to this lesson and try to understand the basic concept or on what are semiconductors and how do they work, right? So now you've understood, I mean, why are we going to study this lesson? So let us quickly talk about why this semiconductors, or how the semiconductors came into picture. Long back, it was seen that objects like, I mean, people were always more interested to make use of controlled flow of electrons. I mean, all of you know that flow of electrons constitute nothing but electric current. So electric current is something which is extremely useful to us. And electric current was put into several practical purposes. But that electric current should be in a controlled manner, because if a huge amount of current pass through a circuit, it can damage the circuit. It can damage the components present in the circuit. So controlled flow of current was extremely important when you try to put current into practical purposes, right? For safety. So earlier it was seen that valves were used for this purpose. What was valve? What were valves actually? Valves were nothing but an electronic component, or you can say it was a device. In fact, you can say it was the only device during that time which allowed unidirectional flow of current. That means which allowed current to flow in one direction. So when I'm talking about controlled flow of current, I'm talking about the current is flowing in a controlled manner in one particular direction. So valve was the only device which allowed this unidirectional flow of current. But later it was found that when semiconductors were gradually introduced and when the properties of semiconductors were gradually studied, and then it was found that these semiconductors were more advantageous and they were good enough to replace valves. So there were certain disadvantages with valves. For example, it was very bulky. It involved high power consumption. It had limited life. So whenever you have limited life, that means the cost involved would be more, because it will get spoiled in a small amount of time and then again you need a new one. It involved high operating voltages. So these were some of the disadvantages of valves which the solid state semiconductors were able to overcome. They were small in size, low power consumption, long life, and low operating voltages. So that is how solid state semiconductors successfully replaced the valves. One very good example which I'll talk about when I'm talking about this is, all of you must be having a television at your home, right? So if you look at televisions which are quite old, maybe some 20-30 years back you had purchased a television and it is still there at your home, then you would see that inside these televisions they actually made use of valves. Now what actually were valves? Valves were nothing but it was an arrangement where there were two electrodes. One was a hot electrode and the other one was a cold electrode, and the space between the two electrodes was nothing but vacuum. So now electrons were emitted by the hot electrode and it started flowing towards the cold electrode through that vacuum. So this controlled flow of electron was put into practical purposes. So if you listen to this arrangement, you can say that it must be bulky, right? Whereas in semiconductors, no such arrangements were needed. We will talk about semiconductors just now, and then you'll get to know how current flows in a semiconductor. So in case of semiconductors, what happened? Controlled and unidirectional flow of electrons took place inside the solid itself. So there was no external heating which was involved. Whereas in case of valve, there was some external heating involved to keep one electrode hot and the other one cold. There was a space between the two electrodes which was like maintained as a vacuum. So I mean, a lot of space was involved, external heating was needed, right? Whereas in semiconductors, everything happened inside the solid. Nothing happened externally. So obviously it will be compact, right? So as I was telling, the example of your television. Earlier you have these televisions where you used cathode ray tubes. Inside the television for the construction, you used the cathode ray tubes, which were nothing but an application of valves. But gradually they got replaced with your LCD. And now even LEDs have started coming up, right? So in LCDs, that liquid crystal display, what was that LCD? LCD was nothing but the solid state semiconductors. So the solid state semiconductors gradually replaced the valves. So this television is a good example, because all of you would have seen that how these LCD TVs took over the old television sets. These days hardly any of you buy normal television sets. Why? Because as I told you, these valves will have limited life. So your picture tube, some of you call that as picture tube, might get disrupted very quickly. So the television will not have a long life. So people will prefer to go for LCDs. So this is all about how the semiconductors came into picture. And not only that, just because it overcome the disadvantages of valves that came into picture, it also had, it found its application in many different fields, in medical fields, in defense, industry, communication, where you have this radio, TV, satellites, tape recorders. So in all different fields, the semiconductor electronics had marked its application, and that is why it became so important and significant. Now let us come to the main topic, and now let us start discussing the concepts in this lesson. So we'll start with what are semiconductors, because first we should know what it is, right? Only then we can study about its properties and characteristics. Semiconductors, as the name suggests, is something between conductor and insulator. Semi, the word semi means partially. It is half conductor, half insulator, something like that. So when I compare the semiconductor with conductors and insulators, what do we see? Conductors, when I talk about conductors, they have got high conductivity. Of course, when I talk about insulators, they have got low conductivity. But when I talk about semiconductors, they have got intermediate conductivity. That means their conductivity is lesser than conductors but greater than insulators. So conductivity is inversely proportional to resistivity, right? If the resistance is high, the conduction will be low, because resistance is nothing but a barrier to conduction. So if conductors have high conductivity, it is quite obvious that they have low resistivity. Insulators will have, on the other hand, very high resistivity, and semiconductors will have intermediate resistivity as well. Now, let us look at some of the examples. When I talk of conductors, we remember metals. Mostly metals are conductors. Water is a good conductor of electricity. When I talk of insulators, we think of plastic, wood, glass. All these things are insulators or bad conductors of electricity. When I talk of semiconductors, we have elements like silicon and germanium which act as semiconductors. That means they can conduct electricity but not as good as conductors. Other than that, we also have compounds like gallium arsenide, polyaniline, which are all semiconductors. So now roughly you know what are semiconductors. Thank you. Please visit examfear.com to watch free educational videos, try free online tests,
Get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.